Hi, this is Professor Scott Norman. Today we're at Pittsburgh State University in the Automotive Technologies Fuels Lab. Today's micro lesson is going to be on pressure, vacuum, and how it relates to combustibility of fuel and air in the internal combustion engine. So we have a little bit of a hard time, technicians and my students have a hard time understanding maybe a relationship between pressure and vacuum, and it's hard because those two units of measurements are not necessarily equal. We use a pressure gauge a lot of time to measure fuel pressure and transmission pressure, oil pressure. So we're pretty familiar with PSI or air pressure in our lines. So that's a fairly normal measurement that we take. We measure engine vacuum. We measure vacuum. We apply vacuum to things, and so we could also measure that. But when we start comparing the two, or comparing it to the map sensor, it sometimes gets a little bit confusing, and so this video will hopefully try to help straighten out some of those confusions, we'll say. So in our automotive fuels class, we have a question that we ask our students, and I'm going to read this out, and that is the pressure drop across the throttle plate in a gasoline engine at 20 inches of vacuum is about how many PSI? So again, we're trying to do a vacuum PSI comparison, and so that's sometimes difficult for the students to try to figure out. The second question is the absolute pressure in the manifold of an engine, either at 20 inches of manifold vacuum, is about how many PSIA. So here I just introduced a third measurement. So we have PSI. We have vacuum in mercury, and then we have PSIA, or pounds per square inch absolute. So I'm going to try to explain that a little bit so you guys are able to understand these type of questions and be able to figure them out. So the first things that we have to know or realize is that I drew a chart over here, and so what it tells us is that this guy right here is atmospheric pressure. So that's one atmosphere of pressure is what that is. And so PSI is typically on the high side of that line, where we're adding pressure to atmospheric pressure, and inches of mercury is on the bottom of that line, where we're taking away from atmospheric pressure. So some of the things that you have to realize is that one atmospheric pressure equals about 15 psi, 14.7 psi at sea level, but we say somewhere around 15 psi, round up. Also, one atmospheric pressure is about 30 inches of mercury, okay? 2 inches of mercury equals about 1 PSI. So when you start thinking about that, you have to realize that the mercury scale, or the vacuum scale in inches of mercury, is more precise. There's more units of measurements in the same amount of period. So if I go from this, a perfect vacuum, we'll say at 29.92, all the way up to atmospheric pressure, well, that's around 30. Well, if I'm measuring in the PSI, it's only 14.7 or maybe 15 if you want to round up. So as a kind of a way to think about that, if I wanted to put 4 inches of vacuum to some particular item, well, that's roughly the same pressure as 2 psi. So when you look at vacuum versus pressure, they're both a measurement of pressure. It's just that they're just the opposite of each other. So as an example, I can take vacuum out of this water. I got some straws here. Nice fresh water. That was good. So I could use vacuum to pull that water up. I could also use pressure to push that water out. So I can use pressure to push that out. And so the key is that I could take, let's say, a ball, and I could shoot 1 inch of PSI of air pressure at that ball, and it would maybe start moving. Well, I could also take a vacuum cleaner, we'll say, and apply 2 inches of mercury on the other side of that ball, and that ball would still move. Okay, I'm trying to pull that ball versus push that ball, if you want to say that. Another way to look at that, as far as that, is that I have a slack tube manometer here, is what I have, and I have it filled up with water is what I have. So if I take a simple vacuum gauge and put it in there and apply just a little bit of vacuum, my vacuum gauge didn't hardly read at all. It hasn't really, it moved, but I can't really take a reading on that. Well, that moved 14 inches is what that is. 14 inches of water. So I can take a vacuum and I can get that water to move 14 inches. I could also take this straw or this hose and I could blow into it and apply a little bit of pressure and also get that water to move 14 inches, you know? So I could apply pressure to one side and push that water up. I could apply a vacuum or a lack of pressure, if you want to say that, to this side and also get that water to move up. So I'm using water as an example because, you know, that's easy to kind of think about. And so when you start looking at water, 34 feet of water equals 1 atmosphere. So like, whoa, what does that mean? So if I take a big tube that's 34 foot tall and put a vacuum pump on it and try to get a perfect vacuum, the water is only going to be able to be pulled up 34 feet. It won't be able to pull up any more than that. So that's kind of what that means. 28 inches of water equals about 1 PSI. So if I put 1 PSI into this flat tube manometer, just 1 PSI, try to dial down my air pressure as low as I can, well, it only goes up to 16 is the highest it goes up to for my gauge. So if I put 1 PSI here, it's going to blow water out all over the place. So inches of water is a very small measurement. And so the reason why we use inches of water a lot of times is that my PSI is just too large of a measurement. It's like trying to take a tape measure to measure the bore of your cylinder when you're trying to figure out around. You know, it's going to give you an idea. You know, hey, is this a 3.5 inch bore or a 4 inch bore? But it's not going to be able to tell you how to round. You need a dial bore gauge or an inside mic, something a little bit more precise in order to make some fine measurements. So we tend to use inches of water as far as a measurement when we start getting into the evaporative emission system on a car. So 28 inches of water equals around 1 PSI. So 14 inches of water equals around 1 inch of mercury. So again, if I just take 1 inch, a vacuum of 1 inch, well, it's kind of hard to see 1 inch of mercury on this one inch because that's what my gauges are set up as far as vacuum. I can pull this up and I can try to get to 14, you know, pull this thing up to 14. And again, my gauge, oh, is that 1.5? Is that 1 1/4? Is that a little bit underwater? Again, these gauges just aren't very, very precise. And so we tend to use inches of water as a better measurement tool. It's just more precise as all it is. So you have to realize that there's a relationship between inches of water and vacuum, or inches of water or PSI and inches of mercury. If I filled this thing up with mercury, you know, well, trying to get this thing to move, well, I wouldn't be able to get it to move past 14.7. 14.7 would be the highest amount I could get. Mercury's very heavy. If I put a perfect vacuum on it, it's only going to go up to 14.7, and that's as far as it's going to go. I can't physically get it to go any higher by creating a vacuum on that. So let's take a look at this chart over here, and then let's kind of look at the relationship. So again, we're typically looking at PSI, you know, so if I add pressure, you know, if I look at my oil pressure and see what that is, you know, 30, 40, 50 pounds of pressure, that's fine. If I'm looking at the intake manifold vacuum, I'm normally looking at inches of mercury, you know, my engine vacuum. And so, as far as the amount of vacuum I could get, you know, perfect vacuum, we'll say 14.7 is a 29.92 is kind of at the lowest is what it is. And remember that this is a 2-for-1 value. And so for every PSI I move 2 inches of mercury. So that's kind of what you want to think about. So we have this thing called PSIA, pounds per square inch absolute. And so why do we even talk about pounds per square inch absolute? Well, we got this saying on our car called the MAP sensor, MAP, manifold absolute pressure. And so the MAP sensor is not really reading vacuum, it's reading pressure, like any other pressure sensor on a car. The AC pressure transducer, transmission pressure sensor, your oil pressure sensor if you have an oil pressure sensor versus a switch, but they're all measuring pressure is what they are. They're not measuring vacuum. So you have to know a little bit about PSIA. So if I look at the PSI gauge, which is actually an easier gauge system to try to figure out, kind of like the metric system, I think about it, but it's easier to figure out than the US, you know, imperial system of measurement. But anyway, at sea level, you know, if I don't have any PSI, if I don't have any inches of mercury, think about your engine that's off. Well, you have 14.7 pounds per square inch of air pressure pushing down of air in that engine. And when you start looking at the way the engines operate and power It's all about the air. It's all about how much air you can get in that engine. Basically, oxygen in air is what we really need in order to get the power out of it. So you have to realize that that the PSIA gauge, the absolute gauge, starts at 0. So at a perfect vacuum, 29.92 inches of mercury, it starts at 0 is what it does. And at atmospheric pressure, it's 14.7 PSIA. I could call that 1 bar. I could call that 101 kilopascals. You know, that's 1 atmospheric pressure is what that is. So again, there's lots of different measurements here. PSI would be 0, mercury would be 0, PSIA would be at 14.7, the bar scale would be at 1, the kilopascals would be at 101. So, you know, at atmospheric pressure. We typically zero out our gauge, so we don't read this, but when we're measuring atmospheric pressure, when we're measuring PSIA, we do. So what you want to look at is what I did is I divided out atmospheric pressure versus the lowest reading we have. And so again, I got 0 PSIA, I got 29.92 inches of mercury. And what I did is I just divided them into 3, because that's an easy thing to do. So if I put a third and a third. So at a third, if I'm measuring at PSIA, it's at 5. If I'm at this 2/3 value, then I'm at 10 PSIA. Then of course we're at 14.7. If I come over here and do the same thing, well, if I'm down at my 2/3 level, we're at 10 inches of mercury. So I go 0, 10, I go 20, round that up to 30. So let's go back to that question I asked. The question I asked is, what's the pressure drop across the throttle plate in a gasoline engine at 20 inches of vacuum? So this is what we have to think about. So at 20 inches of vacuum, I am at 5 PSIA. So I'm at idle, you know, that real good strong 20 inches of vacuum. So think of this as your cylinder or your throttle plate. This is my throttle plate right here. So I got 14.7 PSIA on the top of that throttle plate, you know, atmospheric pressure pushing in. And if I'm at 20 inches of vacuum, I got 5 pounds per square inch still in that cylinder. It's not a perfect vacuum. You know, engines don't make a perfect vacuum. You know, they're around 20, you know, is pretty good. So if I look at the pressure drop across that, well, 5 minus 14.7 is around 10. So the answer is that you have about a 10 PSI drop across your throttle plate at idle, at 20 inches of vacuum. The next question is what's the absolute pressure in the manifold of an engine idling at 20 inches of manifold vacuum is about how many PSIA? Well, if I'm at 20 inches of PSI, if I'm at 20 inches of vacuum, then my PSIA is going to be around 5. And let me tell you a story. I bought this was years ago. I bought a 2003 GMC Yukon, Chevrolet vehicle with a 5.3, and I was working for Chrysler, and I just bought this Yukon because I had a large family to drive around, and Chrysler didn't make a big vehicle like that. But anyway, I was having a problem. It was running lean, and check engine light came on, and I grabbed a scanner that was an aftermarket scanner. I wasn't real familiar with it, but I remember looking at my mass airflow sensor. I'm looking at my short-term and long-term, and all of a sudden I noticed while sitting there at idle that my map sensor was reading 5, and I'm like, wow, I wonder if my map sensor is bad. You know, I don't have any map sensor fault codes. I'm looking for a voltage reading. I'm looking for a vacuum reading. All I see is 5, and I'm like, wait a minute. Is that 5 inches of vacuum? Is that 5 PSIA? And I had to really think about it because when I first saw it, I'm like, oh my God, I got 5 inches of vacuum. My engine is shot. I bought this vehicle. The rings are bad. There's something wrong on the map sensor. You know, I remember hooking up a vacuum gauge to it, and my vacuum was fine. It was around 20 inches of vacuum. So I'm like, okay, so I have a bad map sensor problem. But then I remember, wait a minute. The scan tool is not giving it to me in inches of mercury. It's giving me into PSIA, which it didn't say that. It just said 5 is what it does. And so I realized, oh, my map sensor is reading right. And so you have to realize that your manifold absolute pressure sensor is measuring pressure. And so when you think about that, what you want to realize on your map sensor, I'm going to erase this, my little manifold here, is that when I look at as my pressure goes up, PSI goes up, that means that the resistance of that sensor inside is going to go up, and the voltage is going to also go up. So with pressure sensors in general, you know, AC pressure transducer, oil pressure sensor, transmission pressure sensor, your MAP sensor, your manifold absolute pressure sensor, you know, the voltage and the pressure go up and down together. So think about this: when you're sitting with the car off, the car is off, you're reading on your MAP sensor around what, 4.5 volts or something like that. Well, when you think about that, with the MAP off, with the MAP sensor with the car off, I got 14.7 above the throttle plate. I also got 14.7 below the throttle plate. That's going to be the highest pressure I have, unless I have maybe a turbo or a supercharger on it that's pushing the air in from the top. So the key is that my MAP sensor the voltage is going to be 4.5 volts because the pressure is very, very high. Well, when would the pressure be the lowest? Well, the pressure is going to be lowest when the car is at idling or maybe on decel, to where I have, you know, 20 inches of vacuum, you know, I'm down around 5 PSI at the absolute. Well, when you think about that, well, my PSI is down. Think about your MAP sensor at idle. It's reading around 1.25 volts. It's not reading anywhere around, you know, 4.5 volts. Think about wide open throttle. When I go to wide open throttle, you know, well, at this point, my throttle plate is opened up all the way. I got 14.7 on the top. I got 14.7 of air going in. Well, I mean, at least it could be that, you know, if I have a supercharger or something on it. But the bottom line is that my voltage shouldn't go up the same as with the engine's off, but it should go up pretty high, you know, 3.5 volts, maybe 4 volts, you know, something like that. So the key is that your MAP sensor is reading absolute pressure, and understanding absolute pressure is kind of important when relating to engine vacuum and also measuring PSI, because there's really 3 different types of measurements that you have to look at. When you start looking at PSI in general, you know, if I say I got 100 PSI absolute, well, that roughly equals around 85.3 PSI on the regular gauge, you know, the regular fuel gauge that we're normally dealing with, working with. You know, you take 100 and subtract 14.7, and that's where you get your 85.3. So for every PSI change on your regular gauge, you know, like your fuel pressure gauge or something like that, well, that's the same units of measurements that's going to change on your absolute gauge. See, that stays the same. So only when I get down below atmospheric pressure here is where we go and we change it into units of mercury, because mercury is a finer measurement than PSI, where it sometimes gets confusing for technicians. Hopefully you enjoyed the micro lesson, and if you're looking for more automotive educational videos, you could subscribe to my Professor Pentane YouTube channel. And I'm also have a website. Just look for ProfessorPentane.com. Thank you very much. You guys have a good day.